for a cricket of mass 0.01 kilograms is vibrating up and down with simple harmonic motion. Its amplitude is 40 millimeters and the period is 2 seconds. Let's just be careful with this. 40 times 10 to the minus 3 meters. The velocity at the center of the oscillation. So hopefully we remember that the velocity is a quantity that varies in time. When we write it down, we'd write minus omega a sine omega t. But we're interested in the velocity at the center, which is when sine will be equal to 1. So the velocity maximum at the center is just omega a minus omega a, but the minus sign doesn't matter too much here because we just want to know the value of the maximum. So here we can use the idea that omega is 2 pi over t. We can multiply that by a. So we've got 2 pi over the time period, which is 2.0 seconds, times the amplitude, which is 40 times 10 to the minus 3. So gives us a value of 0.13. The acceleration at the center of the oscillation, well, this is even easier. So again, the acceleration is a function in time, minus omega squared a cos omega t. But we also know that the acceleration is directly proportional to the displacement. At the center, the displacement is 0. So the acceleration is 0 meters per second squared at the center. Part C, it's velocity 10 millimeters from the center. So this is a bit harder. The only way of solving this is to find the time at which it's at this position, and then from that use the velocity equation. So we're going to start with the displacement equation and solve it to find the time at which this happens. So the displacement is a cos omega t. We want to solve for t, so we can say omega t is the inverse cos of x over a, or t is equal to omega times the inverse cos of x over a. I'm going to carry on up here, so I've got some space. So t is equal to omega, so that's 2 pi over the time period, which we already know is 2 seconds, multiplied by the inverse cos of its current displacement, so that's 10 millimeters, over its amplitude, which is 40 millimeters. Here, the millimeters cancel out, so we can leave off the powers of 10. This is 10 millimeters over 40. Obviously, it's the same as just doing 1 over 4 as well. So when we make sure our calculator's in radians and then work this value out, so it's pi times the inverse cos of 0.25, which is 4.14. I've done the wrong thing here, haven't I? I multiplied by omega. I should have divided by omega in here. Let's put that right. So this is over 2 pi over 2. That's right, I had an answer that was bigger than 2 seconds, which is obviously going to be wrong. So I need to do the inverse cos of 0.25 and then divide by pi. There we are, so 0.41 seconds, 42 seconds, in fact. So as always with these things, it's worth just thinking when you get your answer out, does that sound reasonable? Well, my answer to start off with was 4 seconds, which clearly isn't reasonable because the time period is 2 seconds. So now we know the time at which its displacement is 10 millimeters. So last part is we want to find its velocity when its displacement is 10 millimeters. So we're going to use V. Let's use a new color so it's a bit clearer. V is equal to minus omega a sine omega t. Well, it's already in the form that we want. So omega we know is 2 pi over 2.0 times A. Here we do need to get the units right, so 40 times 10 to the minus 3 multiplied by the sine of omega. That's again 2 pi over 2.0 times t, which now is 0.42. So we've got pi times 40 times 10 to the minus 3 times the sine of 0.42 times pi gives us a speed of 0.12 meters per second. Again, quick reality check. The maximum speed was 0.13. When it's just a quarter of the cycle away from the center, we expect it to have a velocity that's very close. Let's just quickly sketch a sine graph to show that. So the speed follows a minus sine graph like this. We know the total time period is 2.0 seconds. We know the maximum speed here, max, Vmax, happens for a quarter of a cycle, so at a time of 0.5 seconds. Our speed when it's 10 millimeters from the center happens at 0.42. So we're about here, 0.42 seconds. And you can see that on a sine curve, the value of Vmax and the speed at 0.42 are incredibly close. So we think this is 0.13 and 0.12. So that looks very reasonable to me for a value. So we're happy with that. D, its acceleration 10 millimeters from the center. Much easier to do this part because of the definition of SHM. A is minus omega squared x. A is directly proportional to the displacement by this constant. So minus omega squared again, so 2 pi over the time period, let's write it out properly first, squared times the displacement, which we know is, let's leave it as x for now, and then we'll put the numbers in. So that's 2 pi over 2.0 squared times the displacement, which is 10 times 10 to the minus 3. So it's pi squared times 10 to the minus 3, sorry, times 10 times 10 to the minus 3. Pi squared times 10 times 10 to the minus 3 gives us 0.099 meters per second squared, because it's an acceleration. Does it look reasonable? Well, yeah, much harder, isn't it, to judge? Do accelerations look reasonable? So we will say yes. It's kinetic energy at the center. So a couple of different ways we can do this. We worked out its speed at the center earlier. We got it up here as 0.13 meters per second. Alternatively, since we know that Vmax is equal to omega A, then we can say its maximum kinetic energy, it's a strange way of writing it, its energy kinetic maximum is equal to half m Vmax squared. So that is going to be a half m omega squared A squared. So that's a half times the value of m was 0.01 times omega squared. Well, as we know, this is 2 pi over 2 squared times A, the amplitude is 40 times 10 to the minus 3. 0.5 times 0.01 times pi squared times 40 times 10 to the minus 3 is 1.97, so 2.0 to two significant figures times 10 to the minus 3 joules. And last part, state the value of the maximum kinetic energy and the position when it occurs. Well, we've just said, haven't we, it happens at the center. So here it just said the kinetic energy at the center. Now it's asking us, where's the kinetic energy at maximum? Well, the answer, of course, is at the center. That's when velocity is a maximum, and then therefore its value, wrong way around again, E K max is equal to 2.0 times 10 to the minus 3 joules.